Hey, this is Dr. Wickman. I just wanted to make sure you know about class. Okay. Okay, let's see. Chapter 2.2. Is Alicia here yet? Does anybody know Alicia? Marino? Anybody? All right, and we said we're on page 80. See if this will get us there. And this is Dr. Wickman. I just wanted to check to make sure that you knew we had class. Bye-bye. All right, let's see if this gets us there. And here we go, 2.2, 84. This is someone that said, and here we go. You guys cannot see it, can you?
No, sir.
All right.
No.
All right. Is anybody pretty good? Well, heck. Yeah, that's not going to work.
We have a test next Tuesday or Monday. Is it Monday?
Is that what it says?
The 14th?
Is that what it says?
Yes.
I guess you do then. The answer would be yes.
Where are we going to take it?
Let's see. Where would you like to take it?
I'm not sure.
Well, when you figure out where you'd like to take it, I'll send it to you there, okay?
Oh, okay.
We have to do the review first. And then
Oh,
we have to determine when it's due.
okay.
And we have to determine if you can get help doing it. Does that all make sense?
Yes.
I don't know how it can, but I hope it does. On the midterm, you guys will get an exam. You get to have help to do it. And you can do it anywhere you want. You can do it as a team. You can do it online together. You can get Einstein to help you. Now, it'll be different than the final. Final, you have to do by yourself. But anyway, I want everybody here to get an A on the midterm. If you don't get an A on the midterm, then you didn't get help. So let's look at number one. Determine whether the correspondence is a function. Now, the simplest way to did I answer your question enough about the midterm? Probably not. Did I? Ask me some more if you want to know.
Okay.
What do you have? Any more questions?
No, sir.
Okay, I don't think I've even built it yet. I'll have to look. All right, so the example one, determine whether the correspondence is a function. Well, let me just say this. If the correspondence is a function if the x has only one birthday or one y. So, for example, Ulissa and Naomi, Tamara, Maria, Ashley, all you guys would be the X's. And you can only have one birthday, so you could only have one Y. But Maria and Ashley could have the same birthday. So I hope that makes sense. So determine whether or not, in example 1, the numbers 1, 2, 3, and 4, F is a function. And of course it is, because look at all the money amounts are different. But look at G. Is G a function? Yes, it is, because even though 5 and 6 have the same Y, it's legal. But what's not legal is H. Chicago has the Cubs and the White Sox, so that's not a function, although it really is because it has them both. But notice Chicago has 2. Naomi, you got a question?
No, sir. Sorry.
Okay, I just want you guys to know. Can you still? Let me go back to that. That I cannot see you if you raise your hand. I can only hear it, maybe. So that's why I thought maybe you had a question. All right, let's go to number 2. Determine whether each one is a function. I don't like those examples. Let me give you see a different one. One that will be on the test, like that deals with, well, I mean, you can use, I gave you the symbolic one. I can give you the numerical one too. And this should do that. Let's see here. Okay, so if we look at this appointing president Supreme Court, it is not a function. Why? Because Bill Clinton appointed 2 people, as did Barack Obama. So the X's have 2 Y's. You can't do that. So it's, as B says, it's not a function. Now on the test, it's going to say something is a function, yes or no, and why. And the answer is yes or no. It's yes because X has only 1 Y. No, if X has 2 Y's. That's it in a nutshell. Now, let's go to the next one. Again, you guys, if you don't understand, if you got a question, you guys know I love questions. And by the way, I'm just happy as can be to be here today. You gotta know that's a lie, because I'd rather be off too, just like you would. But I was told this math class had to have a class today. So here we are with a smile. Okay, so number 3. This is a function. A function, instead, notice this quickly. What's the difference between a regular equation and a function? Well, y equals 6x plus 2. This is a line, but it is also a function. Now, a function, instead of saying y, we say f of x. So if you see f of x, what does f of x really stand for, class?
Function.
Y. Yeah, and a function. Both are right. Both are exact answers. F of x stands for y. All right, let's go. So, okay, now, in number 3, they're just saying simply put this in for x. F of x, the x portion is the 0. F of x becomes y. So if you plug 0 in, you're going to get 8. The -5 stands for the x. But once you plug the -5 to the equation, you get f of x, which is the y. That's all it means. So f of 0, the 0 part for a stands for the x. You plug it in, and then once you plug it in, you get your y. So let's do number A and number 4. F of 5. What does somebody get for that? Nobody? Nobody out there?
What is the question?
Say the question
A.
again.
Can you see A? That's the question. What's F of 5?
It's just telling you the y.
Wait, like y equals 5?
Because if we're plugging it in, then it's 17, right?
That's exactly right. It's 17. The 5 stands for the x. You put in x for that. You get 3 times 15 is 17. So the f of x portion is 17. The 5 is the x. That's all you're doing. So what's g?
So it's also telling you the x, the -2.
Okay. So,
Would it be 5?
no. How do you get 5?
-5.
-4?
How do you get that?
It'll be 14, won't it? 2 times.
What?
Well, if you have to move it to the other side, it would be a positive, right? So it would be 7 plus 2? Or do we not do anything to it?
What is -2 supposed to stand for?
For X.
Yes.
There's no X. Yeah, the 7 is just by itself.
Okay. So this would be what? What would all, if you have the -2 and 7, what would you have for the answer?
So it just tells you it equals 7.
So what it
So it would
says
be
is,
7.
you told me that the -2 stands for what?
The x, and so
X.
g of x is the y. 7 is the
And then
y.
the other parts, so exactly. It is simply the y, and g of x equals 7, and that would be the y as well to plug it in. So look, you'd have the ordered pair, -2, 7. The 7 stands for the x, the y, and the -2 stands for the x. So you'd get an ordered pair of -2, 7. Now that's the most complicated problem you're going to get for this whole thing. What you saw in A is very much what you would see. Let's get out of this page because it's too complicated. You'll never see that. What we'll see is what will come up next. But one stands for the X, the other one stands for the Y. It will make sense to you much more after we leave this class. What you got there was an ordered pair. See the slides down. Okay, now, this will be a good example. F of x equals x plus 2. Obviously, f of x means y. There you're given your x, the first one in this t-chart. Can you see -4?
Yes.
Yes.
Okay, you plug -4 into x, and you add it to the 2, and you get -2, and that's what the y is. X is -2. Oh, so, Cibriana, you're in class. Is that a yes or no?
Yes, I'm here.
Good deal. Let me ask also, is Alicia Moreno here? Nobody has any contact with her or knows her? Okay. So the x, like if 0 is x, that's usually the easiest one, y becomes 2. So is that making sense? And this is a line. And if you wanted to graph this line, you know how to put that in the calculator, right? F of x is really y, and you have x plus 2, so you go to your calculator. It's easy to do. This is what you should know. Bring up my calculator. Let me clear it. F of x, that means y equals. So we're going to put x plus 2. X plus 2. Now, we have another one that's graphed right below us. Let's clear that one out. Just going to clear that whole thing out. We're going to go back up to the other one and just simply hit graph. We don't hit enter, we graph it. And there it is. That's the line you see. And now if I want the chart, which you just saw in the book, we hit second. And we hit the same thing, graph, but since it's second, it gives us the blue stuff, table. There's the table. That's the stuff you see. It's unbelievable for your calculator, helping you. All right, let's go back. I think that's all what you did on that. So that's number 5. That's how you get all that. Let's go to number 6. Taking a long time. It's ridiculous. There it is. G of x equals 4 minus x squared. So since we have a square, we know it's not a line. Gx stands for the y. You could put any number you want in for x. So you build a t-chart. This t-chart shows, I always would put 0. Right here is 0. Make it better. I'm going to make this a little better. There we go. If you put 0 in for x squared, it becomes 4. And that's what you have, 0, 4. And by the way, in any particular graph, if you can make the x portion 0, that is the vertex of the line. If you have a negative in front of the x squared, it does not hold water. That means this graph, if you put water, it would not hold it. That's a very critical thing I just told you. If you have a negative in front of the x squared, the graph goes like it is, goes down. If it's positive, it goes up. Now, 4 means it goes up 4 spots. Now, if you wanted to put this in your calculator again, it'd be easy, and we should. We're going to do 2 of them. Notice that we have here, it says 4 minus x squared. Normally, you would write that is g of x or y equals a negative x squared plus 4. Is everybody okay if I write it like that? Negative x squared plus 4?
Yeah.
Because it's just putting the x first, and that's the order it should be. So let's stop this. Let's go to our calculator one more time. Let's look at what we can do and what we're talking about here. Make this make sense. We said if we went to our calculator, that's not good. Yeah. We said we went to our calculator, y equals, we said we have a negative, I can clear that out. Negative x is up here, squared, we go upper arrow squared, we push out there plus 4. And we graph it. Boom. And notice we get just like that. Oh, did we put in negative? No. We put in a positive x squared plus 4. It's like I mentioned to you, it would hold water. Aha. Now let's do the negative x squared plus 4. And watch what happens. You're going to get the exact same graph, but it's going to go down, and we're going to get a spider, I think. Let's see. There we go. Notice one is blue and one is red. Well, that's because the graph said so. The first one is blue, the second one is red. We can put a third one, we get colors. That way we can keep all the graphs straight. It's really cool. And that's what I wanted you to see, the difference between a negative and a positive. Number 7, the vertical line test. Well, what does that mean? See what it says. Well, I got a feeling it's this. If you put a vertical line something and it runs through the graph one time, it's a function. Let's see. While that's going on, we never did hear from Alicia. Okay. So
It's very blurry.
it is.
Yes.
Thank you. So on a graph, it is possible. If it is possible for a vertical line to cross the graph more than once, then it is not a function. So if I draw in a vertical line, can it go through this graph twice? In fact, it goes through it 3 times. So it's not. In B, it's a function. So look at A, it's not a function. And B, it's going to say it is a function. So that's called the vertical line test. On the test that you have, you'll get this one. Let's see if we can come up with it. Getting there, I'm sure. Really slow reason. I don't have anything open. The IRS instruction booklet. This is the number of pages. Is this function or not a function, by the way? Blurry?
A little bit. It's clear now.
Yes.
Is this a function or not?
We're not. Oh,
Okay.
yes.
Yeah, it's a
Yes.
function because you draw a vertical line, it only goes through it one time. Now, in reading this problem, in 1975, how many pages were in the book? About. So let's F of 1975. What does it tell you?
40 something pages.
How many pages? About 40 something, okay.
40.
Now, if I say F of the year 2010, you have to interpolate here. That's about right here, and you go all the way up. About how many pages?
Around 180.
Okay, I'll go with that. That's pretty close. That's good. You got it. That's it. All right, number 90, page 92. Come on in, 92. All of us here are looking at I don't know why you're acting so slow. I have an idea. One second here.
It's not clear.
Well, let me see if I can make it clear again.
Okay.
What's the next chapter that we're supposed to? That was the end.
Next chapter is finding domain and ranges, page 96.
90 what?
96.
Perfect. Let's see it. Something's not right. It's taking way too long. What it is. Okay. Find domain and range. You should know that the domain of anything is the X line. The range is the Y line. Alicia, are you here yet? Not yet. Domain and range. So look, if we
It's
have
not
these
clear.
ordered pairs, as you can see,
It's not clear, Dr. Wigman.
okay, thank you for gently letting me know. The X is the domain in every one of these ordered pairs. The Y is the range. That's all they're telling you, number one. Number two, the X again. The number in the range that is paired with the Y is the domain. So if I pick here 0 on X, 2.5 is the Y. That's where it intersects. The domain for this particular function, which you see here, that's this entire curve, starts at -5 and goes to 3. That's the X. The range is -1 to 4. Does that make sense? Let's look down here. The range starts at -1. It's in red, almost. It should be. It's down here, -1. They're plugging it in, but the range starts where the bottom of this graph is, which is, if you look at -5, that point is really -5, -1. So the range is -1. That's your Y. And it goes all the way up to 4. Is there a question about that? Domain and range. Domain is the stretch all the way across from X. And the range is how it goes from Y. Because this is often people make mistakes on the Sunday exam. Nobody? Okay. I'm moving
No.
on. Um, hmm. We're going to set a record here. Okay, now look. This is a better explanation. The x goes from -5, which you can see in the colored bar here,
It's
all
not
the way
clear.
to
The blurry.
3. Any better now?
It's not on there yet. We see you.
You don't see it?
No. Now it's clear.
Okay, so if you look at the colored bar, it's kind of brown. This whole thing goes from -5 to 3. That's the x. That's the domain. The range goes from that -1, which is the blue, all the way up to 4. So that's how you read that. Now, number 3. The domain of this one is infinity all the way to the left and infinity all to the right, because these arrows never stop. But the range starts at 2 and goes -infinity. It looks like it shows here. -infinity goes to the left and the right is this. This is the range. Walmart's doing a lot of business tonight on our program here. Trying to get there. Find the domain of the function on the it goes infinity down, infinity right. So it's just going to be forever. So because it goes up forever, down forever, to left forever, right forever. So there's no ends in point. So it's infinity. Example 5, an absolute value.
Not
An
clear.
absolute value, which is not shown. Pardon me, gently.
It's not clear.
It's not clear.
Okay.
It wasn't clear.
All right. So in an absolute value situation, number 5, this is what it should look like if you were to draw it. If I had a graph and draw an absolute value of x like this, on a graph, if this is my x and if this is my y, if I put in the number x is 1 in an ordered pair x, y in a t-chart, the y would also be 1. Get 1, 1 here. So 1, this is a 1. If I put in a -1 for x, it's over here. That would be my x, but the y would be 1 as well, because it goes up. It's not possible for the y's to be anything but positive. The x's can be, if this is a -3, this would then become a +3. So that's what they mean by it. So the domain for it would always be positive on the right and always would be negative on the left. So the domain for this thing would equal negative infinity on this side and positive infinity on this side. Now the range is the y. The range would start at 0 and would go infinity upward like that, positive, because it can't be negative. That's the range for that. Now, let's look at problems. Let's make it easy again. The domain of 3 over 2x minus 5. I'm going to give you a different one. I'm going to give you over x minus 5. I'm going to change this up because I wanted to make sense for you. I'll make it easier, and then we can go to a harder one. So we have 3 over x minus 5. Now the rules in math is the x and the denominator can never equal 0. What makes this denominator 0? Nobody? What would make this denominator 0, class?
Positive 5?
Exactly. So the domain is all numbers this direction and all numbers this direction except for 5. So x simply cannot equal 5. Because it's undefined, but the domain can be anything. So what is the y? Well, it's anything else. They only want to know about the domain, though. That's your x. And in this case, the x cannot be 5. Because it makes the denominator undefined. Let's go to the next page and probably be fuzzy again where things have been going. So all they're telling you about here is the domain, the denominator, x cannot be 0. Now sometimes you can have it be not 2 numbers. And that's because you have 2 things in the denominator, or 3. So all kinds of things that can cause it to make it 0. Which you know cannot be in the denominator. That's what we're learning in algebra. Cannot have a 0 in the denominator. I bet after all this, it's going to be a fuzzy page. Well, that's the end. We're going to go to the next chapter. What page is that? But I wanted to show you this, though. Let me show you this. Well, I said it could be other things, too. So look, let's say I have this. Let's say I have x on the top. I have x minus 2, x plus 3, and plain x. What can my denominator not be? What can x not be in this case?
A positive 2, negative 3,
What else?
and a 1. Since x is a 1?
0.
Oh, 0.
If this is 0, 0 times anything is 0. It doesn't matter if the other ones are, right? If x is negative 3, 3 minus 3 is 0, and 0 times anything doesn't matter. So I'm going to give you a question. I have pi times alpha times What is the solution to this problem? That's a 3. What is the solution to this problem?
It's the reciprocal of 14 twos.
If this number is 0, 0 times anything is what?
0.
The answer is 0. I want you to see that because a lot of students have trouble with that. All right. 0 times it, what's our next chapter?
It's page 101.
Thank you. This thing is just not working right. I'm almost tempted to sign out, but just 1 second, we can put up with it, I guess, a little bit longer. All right, 101. Do you by chance know what page 2.5 is?
Yes. 0.5 is
that?
108. Yes,
Was
it's
that- that's
108.
right? Thank you so much.
You're welcome.
Appreciate you keeping me track here. I'm confident it won't be like this every night, but it sure is bad tonight. Algebra of functions. The sum, the difference, the product quotients of two functions. All right, this is algebra. So
It's not
f
clear.
of x. So f of x in this particular one is x plus 4. Can you see it now?
Yes, it's good.
Yes, we can see it.
Okay, now g of x is x plus 1. Both these are different functions. One's f of x and one's g of x. Do you all see that?
Yes.
Okay, look at what it says. Find f of 2. Notice this is the f of x function. The x is 2. What number do you get when f of x is 2? Well, you plug 2 in for x, right? What's 2 plus 4?
It's 6.
6.
It shows you right. It shows you right below it. Now, this is the g function. And the g function, g of x, what's the x in that? It's 2. You plug 2 in there, what do you get?
5.
5.
Yes. Notice that f of 2 deals with the f function. G of 2 is the g function. Example 2 now. Now they want to add these. You have the f function, which is x squared minus x, and then you have the x plus 2 function. Well, if you add them, x squared, the x is canceling of 2. And then it says it wants it to be 4. What that means is this. You can do this the hard way and plug in 4 in each of these equations and get the exact same answer. But you're supposed to combine them and then plug 4 in. Let's go to the next page and we'll see once how they do it. If someone would have taught this to me this way, I would have easily got it. Now, they plugged in the 4 in the equation, and they had 4 squared minus 4, that's 12. And then they put the g in there, 4 plus 2 gives you 6, and then add them. But the easiest way would have been the alternative way. It's just to add them. Don't do it the way they have the first one. Do it this way, the second one. What you can't even hardly see. You have x squared minus x plus the x plus 2 because you're adding them together. So you end up with x squared plus 2. You simply put 4 in there. 4 times 2 is squared is 16. 16 plus 2 is 18. And notice they match. So f minus g. You could do the same thing and get 1. F over g. So you put the f equation, that's x squared minus x over x plus 2. And what can x not be in this particular case? X cannot equal negative 2. Why? Because that makes it 0 in the denominator. And then they say put negative 3 in there. The equation is f over g. That's right above it. You put 3 in the top, negative 3, you get 9 plus 3. That's 12 because it's a minus. And then you put negative 3 in here, plus 2, you get a negative 1. 12 over negative 1 is negative 12. F times g of 4. F times g of 4. Well, one of the equations you know is x squared minus x. The other equation is x plus 2. And it says f times g of 4. Let's look at this one. Let's just make this simple again. Let's start over. The first equation was x squared minus 4. The next equation was x plus 2. The guidance was f times g of 4. So we've got to multiply these two things out first and then put 4 in for x. So this times this is x cubed. This times this is a positive 2x squared. This times this is minus 4x. And this times this is minus 8. And then it says plug 4 in there. Well, if you put 4 into here, you get 4 times 4 times 4. What's 4 to the third power?
64.
And then you have 4 squared, which is 16 times 2, it's plus 32. Then you have 4 times 4 minus, so it becomes a minus 16 and a minus 8. So you have 64 and 32, which is 96, thank you. And minus 16 and 8 is 24. I get 72 for my answer. And that's what you have to be able to do. Wow. Something's not right. It says the whole thing's not responding.
Did it kick the professor out?
Looks like
Does anyone have his number?
Does anybody what?
Have his number so we can call him?
No. Oh, it looks like he joined. Or, never mind.
Yeah, he's joined.
Nothing. Yeah, it's not working still right. It's not working right. Okay. All right. All right, class, it's still not working right for some reason or another. I got to get through the night though. Hold on. It's nothing to do with you. It's just to do with the system. So I'm going to have to go back and open the book up for 1 second. And Lizeth, can you tell me what page left off?
Yes, on page 102.
Section, is that 2 or 3? 2.
It is section 2.4.
Thank you. Yeah, I was talking to you guys, all of a sudden it dropped me, and it's still not working right, I can tell. But hopefully I can finish that because we have a few more problems to go. And I apologize. Who knows? Maybe Labor Day is just treating us bad.
We thought you left to Hawaii.
Believe me, that's exactly where I wanted to be. You said 102?
Yes, 102.
Hey, Professor, I have to go. I'm at work right now.
Okay.
So can I just like review it on like YouTube and like watch the rest of the class on there?
Of course.
Okay, thank you.
All right, so here's where we were. Okay. Is this blurry?
can't see it. It's just showing the
No, we need the book.
You don't see it at all?
just showing the chapters. That's all.
Mine shows the book and the pages we need to be. How about now?
It's
Yes.
good.
Yes.
Okay, so everything we talked about should now make more sense. On f of x, 5 over x, what can the domain not be? Or what can it not, what can x not be?
-5.
It can't be 0. X cannot be 0 in the denominator. I should write that down. X cannot be 0 in the denominator. And so the domain is everything but 0. What about the second one, g of x? What can the domain be there? Anything but what?
-1.
Yeah, exactly. Be anything but -1 because 1 minus 1 is 0. So it's all x as long as x is not -1 in that case. So, okay, number 4. What can x not be?
+3.
What about g of x?
Positive.
What can G of X?
7.
It can be anything because there is no denominator. X can be any number because there is no denominator. Remember, it's only the denominator that we're worried about. The denominator cannot be 0 because it's undefined. Write that down. X cannot be 0 in the denominator. That'll be important. But you won't need to write it down because you're going to have it the whole time. It'll just become standard. Now, if they make an equation where x, want to know what simply x is, to make it 0, x is 7/2. It's always this number where when you have 2x equals 7, you always take the 2 underneath the 7. That'll make it 0. But in this case, it can be 7/2, even though it says it can't. The domain is, if you change the equation and put the g equation in the denominator, that means 2x minus 7 is now the denominator. It cannot be 7/2. That's what it is. So g of x on the top, whatever that is, and then the bottom, the 2x minus 7. So I don't know if that makes sense. Let me make it clear. Because this will be the final part. If I have an equation called g of x equals 3x, and I have f of x equals x minus 2. Can you see that? Does that make sense? Can you see it at all? X minus 2?
Yes.
So in the g of x equation, what can x not be?
0. Oh, yeah, 0.
Yeah, x cannot be 0. Now, let's say, and what can f of x be? What can the denominator, what number can the f of x not be? Anything?
Anything.
It can be anything because there's no denominator. Now, let's do this. Let's say I have f of x equals x minus 2. And g of x, g of x equals x minus 3. For both those, the domain can be anything because there's no denominator. But if I write f of x over g of x, you now have x minus 2 over x minus 3. Now, in this equation, f of x or g of x, what is the domain?
Yeah,
It's interesting.
Any number?
3.
Yes, on that.
It cannot be 3 because 3 minus 3 is 0. Does that not make sense? The denominator cannot be 0.
That makes sense.
Yes.
Okay, well, you guys, that's it for tonight. I don't feel like I hit any home runs, that's for sure. But that's the class, and I just want to just check on one thing. Just in terms of my role, did Alicia Marino ever make it in? I guess not. Any questions of me, y'all?
So, sir.
Well, look at that stuff. I'm hoping it made sense. I will say good night to you all. Thanks for coming, and I will see you when?
Wednesday.
Wednesday.
Thank you all. Good night.
Thank you.
Good night.
Look out for that. Look out for that high wave. There, those surfers out there.
Bye.